Hi everyone, this is Melody Rondeau and I'm going to be walking us through our lesson today about angle pairs from intersecting lines. Our learning intention, I'm learning how to apply angle pair relationships. Our success criteria, excuse me, I can find the measures of angles formed by intersecting lines, and I can use angle pair relationships to justify why angles are congruent or supplementary. So let's get started. In our notebook, actually, I'm not sure what page we're on. You guys will have to find it. It is the lesson called Angle Pairs from Intersecting Lines. Sorry, I forgot to look it up before I started the video. So hopefully you guys find it okay. All right, so we're going to start with complementary angles. So complementary angles are angles that form a 90-degree angle, or angles that add up to 90. So we talked about supplementary recently, so these are complementary. So just with the regular writing utensil here, these are angles that add up to 90 degrees. So in our picture, hopefully you see the right angle, the little box here that represents 90 degrees. So within that picture, the overall angle is 90, but then we also have that angle kind of split up into two different angles. And I'm going to use some color to help me out here. I have the first angle up here, which I'm going to call angle 1, and I'm going to actually go ahead and write the measure of angle 1 in red. And then I'm going to switch back to regular writing utensil, and I'm going to throw in a plus sign. Then let's go blue, and I'm going to mark my second angle here, angle 2. And so I'm going to say the measure of angle 2. When I add those two angles together, they are going to equal my 90 degrees. So that is basically what complementary is, when our angles add up to 90. Then we have supplementary. We brought this word up recently in our performance task activity. So let's start with, first of all, supplementary angles are angles that add up to 180 degrees. And in this case, again, I'm going to grab red here, and I'm going to mark angle 1 in red. And then with angle 1, I'm going to just mark off angle 2, because angle 1 and angle 2 would be supplementary. So I'm going to go ahead and say measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. And part of how I know those two angles are supplementary is because together those two angles, I can see, form a straight line. So supplementary angles don't have to form a straight line necessarily. They could be totally separate from each other. They just have to add up to 180. But in this picture, we can see that these two angles do form a straight line. All right, let's go forward. Then we have something called a linear pair. This one specifically has a nice little definition here. We're going to write down. Let me just switch back to my pen. Fantastic. So this is two adjacent angles that form a straight line. Or we might even call that a straight angle. Okay, so a word that I used in there, the word adjacent. This is a word we're going to see a lot during second semester, so we're going to introduce it now. The word adjacent means next to, in case you weren't sure. So for example, angle 1, and I'm going to come back to that in a second. Angle 1 is adjacent to angle 4 because they are next to each other. And those two angles happen to form a straight line. So when angles do form a straight line like this, we call them a linear pair. And so one other thing for us to write down as well is that a linear pair, oopsie, that's not the right color. Let's get the right color. Here we go. The angles in a linear pair are supplementary. And that, of course, is because those angles form a straight line or straight angle, they do have to add up to 180, so we can say they are supplementary. And I'm going to go ahead and write that lovely quick sentence. So the measure of angle 4 plus the measure of angle 3, I'm sorry, angle 1 would equal 180. All right, so just to clarify, because this is very similar to what we said on the previous slide for supplementary angles. So supplementary angles are just any two angles that happen to add up to 180. A linear pair is when we have two angles that are next to each other or adjacent that form a straight line. They also happen to be supplementary, but what makes them a linear pair is that they're next to each other and form a straight line. All right, let's look at vertical angles. This one happens to be one of my favorite angle pairs. Vertical angles are angles that are across from each other. So in my diagram here, I have angle 1 is a vertical angle to angle 3. So angle 1 and angle 3 are considered vertical angles because they are across from each other. But also, I have another pair of vertical angles. Angle 4 is a vertical angle to angle 2 because those two are across from each other. So something you may have noticed about the way I marked my angles, I didn't really talk about that a lot yet, but we might recall when I mark them with the same number of arc marks, that's my way of saying that they are the same or congruent. So something else we can say about vertical angles is vertical angles are congruent. So they are the same. If we look back at our other angle pairs, we talked about complementary angles. Notice I marked angle 1 with 1 arc mark, angle 2 with 2 arc marks, saying that they are most likely not the same. It's my way of saying I don't know that they're the same. So different angle measures. Supplementary angles, again, often different angle measures, 1 arc mark and 2 arc marks. Same thing with linear pair. But when we get to vertical angles, we have some matchy-matchiness. So angle 1 and angle 3. So I'm going to go ahead and write that. I'm going to say angle 1 is congruent to angle 3. And then also angle 4 is congruent to angle 2. So vertical angles are congruent. All right, example 1. Cross braces help keep the deck post straight. Find the measure of each angle. So we're going to do this and we're going to justify our steps here as part of our success criteria at the bottom. Justify why we know the angles are what they are. So I'm going to start off with my favorite here. We have vertical angles. Angle 146 is going to be congruent to angle 6, which means this one also must be 146. So I'm going to say the measure of angle 6 equals 146 degrees. And I knew that because they are vertical angles, and I'm going to actually say the whole thing are congruent. So that's how I know that answer is accurate. Then for angles 5 and angle 7, I've got to be a little more creative here. I'm going to actually switch colors just so I can have some variety. So angle 5 is going to be a different measure, but if I look at angle 5 and angle, the angle that's 146, those two angles together happen to form a straight line. And so if they form a straight line, I know they add up to 180, so I can do some quick math and get my highlighter situation straight. Cool. Quick math, and I can do 180 minus the 146 that I know. So quick subtraction here, borrow gives me 7, 10 minus 6 is 4, 7 minus 4 is 3, and 1 minus 1 is 0. So this angle, the measure of angle 5, would then be 34 degrees. And how I know that is because angle 6 and not angle 6, I'm sorry, I used the 146. So this is kind of weird because it doesn't have a name. So I'm going to say angle 146 degrees. That's kind of a weird way of naming it. That's all right. And angle 5 I can either say they are supplementary or I can say they are a linear pair. Either way would work. I'm going to say they are a linear pair because they make a line. All right, and then finally I can say the measure of angle 7 is 34 degrees. And again, that is because vertical angles are congruent. And that one is vertical. Let's see, vertical angles are congruent. And I didn't mention this before, but I will say vertical angles, it is vertical angles with angle 5. So just in case we're like, how did you know it was vertical angles? Well, angle 7 and angle 5 are vertical. So I'm going to say with angle 5. Okay, there we go. On to example 2, use the diagram to find the missing angle measures, explain your reasoning. So lots of different ways to approach this particular problem. I do want to point out that we are given 90 degrees right here. We're given 50 degrees, and then we're asked to find the remaining angles. So I happen to notice, because I kind of do this a lot, so I'm trained to notice I have a nice straight line right here from, wow, well, that wasn't very straight. Try it again. From B to E, I have a straight line. And I know that a straight line means I have 180 degrees. That's from here all the way around to here. But within that, I have my 90 degree angle and a 50 degree angle. And I'm pretty sure I can use those to find that missing angle. So if I have 50 plus 90, I have 140 degrees. I know the whole line has to be 180, so subtract the 140, and I get 40 degrees. So I'm going to say the measure of angle DFE, which is this piece right here where the arrow is, this section in here, DFE equals 40 degrees. And I know that because in this case it's actually a linear triple. I have 3 angles making a straight line. And I'm just going to go ahead and say supplementary angles. All those angles together have to add up to 180. But I could have said linear pair or triple since there's actually 3 angles there. All right, looking for other things I can connect to. If this angle here is 40 degrees, then I see across from it, I have another angle that would be 40 degrees. That's angle, let's see, BFA is also 40 degrees because we have vertical angles. So that's what we call that one. When they're across from each other, they are vertical. And then to finish it off, just one more angle I need to find, and that is the measure of angle AFE. That's this big one right in here, AFE. That particular one, I again can use that straight line that I already referenced. I know just doing the other side of it. So that would be, let me do it in color so we can see what I'm talking about. My highlighted line, if I go this way to create the line, I have that 40 degrees plus the one that I marked with 3 arc marks. Together, those have to be 180. So I could simply take 180 and subtract the 40, and I get 140. So the measure of angle AFE, the 3 arc marks in there, would be 140. And I know that because those are a linear pair. All right, last examples. The measures of 2 vertical angles. I'm going to pause right there. 2 vertical angles, that you should immediately go, vertical angles are congruent. So I'm going to be talking about congruent angles. The measures are 58 and 3x plus 4. Find the value of x. So if they are congruent, that means they are the same, which means I can write myself this fabulous equation, 3x plus 4 equals 58, because they must be the same. Then I'm going to use some inverse operations to solve. Subtract 4 from both sides. I get 50. Wow, that is not a 50. Try that again. I get 54. And then finally divide by 3, and I get x equals, that's 18, I believe. And I double checked, the question asked me to find the value of x, and we did that. So, done with example 3. Last one, example 4, find the measures of, the measures of 2 vertical angles. So once again, vertical angles are congruent, and we're told they are given by these 2 expressions. And once again, if we know they are congruent angles, we know that means they are the same. All right, so I can build this equation, x plus 3 equals 2x minus 7. I didn't actually finish reading the directions. Let's see what it says. Find the value of x. Okay, so we can solve in just a second. What is the measure of each angle? All right, so this time we have 2 things to do. We got to find x and find the angle. Here goes. Since I have x's on both sides, I'm going to move those together by subtracting x from both sides. X minus x is 0. I get 3. 2x minus x gives me 1x, or just an x. And then I have minus 7. To get the x by itself, I'm going to add 7 to both sides. And I get x equals 10, or 10 equals x, same thing. And that's the first part of my question. Find the value of x. There it is. But I'm also asked to find the measure of each angle. So you can pick either expression, or you can do both of them. I'm going to just pick this first one, x plus 3. If I plug in my 10 and then add 3, I get 13 degrees for the measure of the angle. Since they are vertical angles, they should have the same answer because they're congruent. So I can use the other one, the 2x minus 7, just to check my work really quick. I should end up with the same answer. Let's see, 2 times 10 is 20, minus 7. Oh, look, I get 13. And they are, in fact, the same. And that finishes our notes. Check out the success criteria. I can find the measures of angles formed by intersecting lines. We did that in a couple of our examples. If you got it, check it off. Otherwise, circle it. And our second success criteria, I can use angle pair relationships to justify why angles are congruent or supplementary. And we saw that in the previous examples as well. If you've got it, check it off. Otherwise, circle it. And check out Google Classroom for information about practice assignment. We'll see you guys later.